Okay, does it work now? Let me see. I think
Yeah.
so. Let me
Wait for
see.
call to cloud.
Yeah, I think it's recording now. Is it?
Yes. It is showing, yeah, recording.
Okay. So we have an integer array, okay, and with a given k, in this case, we need to partition the integer to many partition, and each partition is at most the size of each partition is at most k. So let's say copy this. To here. So in this case, k equal 3, right? And we can partition this array into, and we can partition this array into like the following. We can do 1, 15, and 7. That is one partition, and 9 is this, another partition, and the last partition gonna be 2, 5, and 10. Okay, and then the result gonna be okay. The result gonna be the maximum value for each partition. So at index 0, we see in the first partition is the maximum value is 15. So we write out 15. And for the second index, the max partition is 15. And the third index, the max partition is 15 too, right? And then for the next index, we have to go to this partition right here. So it is only one element. So the value is 9. And then the next one, the max partition is 10. The max value is 10. So we put 10 right here, and 10, and 10. Okay. So that is the problem. Anybody have a question on the question?
Yeah, I think just one clarification. So I was just reading the explanation here. So I think this is the final answer is still to maximize the sum, right?
Yes.
So like this is an intermediate step, but the maximum, the output would be like 84, whatever is the sum
Yes.
of this, all right?
Yes. So 84, yes.
Right.
So I have one question, like why, if we are dividing into the subarray of length 3, so why 9 is a separate element?
Yes, because they say we need to divide into partition, and each partition at most is length 3. So the minimum for each partition is length of 1, and the most is length 3. So in this case, we see the first partition, we have 3 elements. The second partition, we see only 1 element.
And I think it also goes back to the maximizing sum issue, right? Correct me if I'm wrong here. So I think we could also have done, for example, keep one separate, do 15, 7, 9, and then 2, 5, 10. But the sum that we'll get after replacing it with maximum value won't be greater than 84 that we're getting from here.
Right.
So I think that's,
yeah.
yeah.
So the sum gonna be, what?
Is there an undo? Yeah.
Yeah. Oh, the sum going to be like, in this case, will be 15 plus 15, right? Plus 15 plus 9 plus 10 plus 10 and 10. So the sum going to be, in this case, the sum will be, 84. Right, if we do, we can do another partition.
Right.
But the sum not going to be, 84. I mean, the sum is not the max sum. So for example, in this case, we could do, like you say, one partition is 15, right? And then the second partition, we can say 7 and 9. And the third partition would be 2, 5, and 10, right? So in this case, the max value for index 0 will be 15, and then for the second value will be also 15, and the third one is 9, because in this partition we see the max value is 9, and the next value is 9, right? And we need to go to the third partition, and the max value, this the third partition is 10. So we put 10 down, put 10 right here, and 10. And then if we compare this array to this array, we see this one is smaller. So the sum not going to be the max one.
Right, right.
Yeah, the purpose is to get the max sum.
Right, yeah.
So any question? Is that clear? Is the question clear?
Yeah, thanks.
Okay, so anyone have anyone attempt to do this and have any approach?
I mean, I can share one. I'm just thinking
Okay.
aloud. I didn't get to see the questions before. One idea I had was maybe look at the, I mean, they're a little open. I have further questions on my own approach, but I was thinking of finding some, like, let's say in this example, if I found 3 largest element, or if I sort the array and not,
Okay.
yeah, I
So
can't even
so
sort
what
them.
is the 3 largest element in here?
Yeah, so that would be 15, 9, and 10, right?
9 and 10. Okay.
So now I have to make this decision that since the question is that I can make partitions maximum size 3, right? So I can
Okay.
even have less than 3, like smaller, the way you had in second example.
Okay.
So now my thought was that if I start from the, so let's say I pick element 15, right? And I look at, now I have to make a decision whether I go with 115, 115.7, or like another partition, right?
Okay.
That time, probably I have to make a decision about if I go with, let's say if I enumerate these, right? 115, 115.7, and then 15, 7, and 9.
Okay.
So these are my options, right? Given k equals 3.
Okay.
I can even do actually 15 and 7 alone, but so at this point, probably I would have to decide amongst like what I have to optimize for the maximum sum eventually, right? So I have to decide which combination at this point is giving me
The max one?
maximum sum.
Okay.
Right? So for example, if I pick 115, then essentially, and then the next step would be replace the every element of that subarray with the max element. So in the first enumeration here, where I have 1 and 15, I'm essentially adding 14 to my array, right? Like
Okay.
when I replace it. And then in the second example, line 18.
Okay.
Yeah. So
Can I can I make one?
Yeah.
Let's simplify it like the way you say. But
Yeah.
let's say the array only have 3 elements.
Right.
So that 1, 15, and 7, right? And we need to
Do the same problem.
okay, yeah, k equal 3. Okay.
Right. So in this case, it would be, my numerations would be 115. I mean, I can just keep the array like that, right? I
Okay.
don't even need to make partition, or I can make it subset, like element of 2, like 115 or 15
Okay.
and 7.
So
But I think the bigger point that we are coming to is, how do I approach, like this can really go very, deep. Like if I start enumerating and computing differences. So,
okay, let's see. So let's say suppose we make it if k we say to simplify it. Let's say in the same problem. Let's say if k equal 1 only, then how would you do it?
k equals 1 would be, that means only single element is possible, right?
Yeah.
Then it's essentially replacing the array with the largest element and giving the sum.
No, if k equal 1, that means we're gonna have in this case we're gonna have 3 partition, right?
Right. But eventually the sum will turn out to be, since nothing is to be replaced anymore, each is an individual partition. So my final sum is only going to be, there's only going to be one possible value, 15 plus 1 plus 7, right?
Yeah. So the result would be 1 plus 15 plus 7.
Right.
Okay. So now let's say if k, now say if k equal 2, then how would you do that?
Yeah. So k equals 2 would be, I can either have this 23 as the sum, or I can start making subsets of 2, like 115
Okay.
and 15 comma 7. This is 23, right?
23, right? Okay.
So here my options are, apart from the k equals 1 option, I have 1 comma 15 and 15 comma 7. Right. And
15. Okay, if you make if you make that, then there's only one partition you can do, right? So
no, there is also, how about the other one, right, where I keep one separate and do 15.
Okay, so that's one option. There's another option would be one to separate, and then you have 15 and 7.
Right.
Right. So if we do this, what would be the
37?
What would be the sum? So
so I replace 1 with 15.
Okay, so we're gonna have 15 and 7, right?
Right.
So in
like
this
37.
Case, yeah.
Right.
The result would be 37.
And the next one result would be 31. Yeah.
So there would be the first element will be 1, right?
Right.
And then 15 and then 15. And the result would be 31. Okay. So any other partition we can make right here?
With k
I think that's it, right?
I think that.
Okay. So in this case, we see if k equal 2, then we have 3 options.
Right.
23, 37, and
31.
And we want to take the max value, right, which is 37.
Correct.
Right?
Yeah.
So now let's say if k equal 3, then what would we do?
Right. So k equals 3, that means everything above and then the complete set, right? 115 and 7,
Okay.
which is what we had pretty much in k equals 1. Like,
Okay, so that would be 15.
actually, yeah,
Oh,
15.
oh wait.
No,
Let's
sorry,
see. Yeah,
you're right. You're right.
1, 15,
7.
and 7, right? And the result array gonna be what?
15,
15,
yeah,
15, and 15.
is 45.
Result will be equal 45. So in this case, we have 4 options.
Yeah.
This one, 45, 31, 37, right? And then 23. So this one, we pick this one because this is the max sum, right?
Right, right. Yeah. I'm kind of thinking about like citing it. It totally makes sense the way we are approaching it, but I'm also thinking of how I can kind of journalize it, because here we are enumerating options and then computing and comparing.
Yeah.
But if we have to scale it up, then
So yeah, so I think this is the this kind of brute force we can do, right, and get a max. But if this the input is a large array, then that's gonna be harder to do.
Yeah. I'm thinking of something like, essentially how to reduce this effort. Can we prune some, like some subsets that we don't need to look at, but maybe if someone else has an idea.
So one thing I'm thinking, like length of the array divided by k. So
Okay.
the maximum groups we have to make, and then means maximum array we can cut into that thing, and means this is from like going from not just we explain about going from 1 to 3, right? So I was thinking an opposite way, going from 3 to 1, and then whenever we are dividing the array, just look for the maximum element should be in that max length array. So in this case, like 1, 15, 7, 9, 2, 5, 10, right? For that array I'm talking. So
Okay.
7 elements, k divided by 3 will be 2 point something, right? So maximum atoms in the array will be the 3. So in that case, we will look that like maximum element should be in the max length of array. So in our case, there is 15, 10, and 9. So yeah, so we will keep 15 in the length of the array is 3 and 10 in the length of array 3, because they are the largest element in the array. But still it is not the, I don't think so it is best option, because we have to find the maximum value elements in the array.
Okay. So you saying keep this what the first partition will be 3 elements like this, right?
Yeah, where is the max element? Like we know the index of the max element, right? 15.
And the max is 15. Okay.
Mm-hmm.
And then what would be the next partition?
So I will see the
9 to 5.
But I want 10 to be on max length array element. So I will go for 10 to 5 in one array, because 10 is the next largest element in the array.
One question there. Right now, when we are looking at this max element, right? When we looked at 15 or 10, we are directly trying to And it fits this example that we are just trying to pick the contiguous ones, right? For example, if there was 10 and then after that there was a 12, then how do we make a decision whether we pick 2, 5, 10 or 5, 10, 12, right? For example, if I had something like this.
Yeah. So then the max second element is 12. So I will make the 12 with the continuous 3 elements should go. Like now length of the array is 8, right? 8
Right.
divided by 3.
Okay. So you want to make that as big as possible, right? So in that case, you would group it like the last one will be 5, 10, and 12, right? So in this group, the max value will be 12. Is that what you're saying?
Yeah, so 12 will be replaced by other 2 elements. When we calculating the sum, right? We have to.
Okay. So what about like we look at it, you know, from a different, like on line number. Okay, let's see. We know that we need to partition to partition the array, and then the max size of the partition would be k, right? So let's say if we say if we say if this one right here, let me see if this, okay, if we say if we pick this one with the last element on a partition, so we don't know, let's say we don't know what the length of a partition is, but we say okay, 15, let's say if I pick 15 is the last element of this partition, then what would be the max value I can get? Does it make sense?
Right.
So you could have many partition. Let's say you could have you know, many partition right here. Let's do a x, right, y right here, right? So if we know, we say okay, if we pick this index, you know, we pick this index right here as the last of one partition, then what would be the max value that we can get? So in this case, if we say,
30.
you know, if we pick 15 as the last index of the partition, and then, you know, let's say in here we pick, you know, 5 as the last index of the partition, and then this is 12, then, you know, what would be the total sum that we can get?
Can I suggest something here? Yeah, I would like to look at this problem a bit different way. Suppose, like, you know, these arrays are there, and I always try to place myself in the picture so that it helps me to think how to proceed further. Suppose I am the last guy in this array. So, and k equal to 3. So how many options I have? Either I could be alone, right, in my own group, Otherwise, I can make a group with the left guy who just came before me. And in that case, all the other people, they will have their own set of groups, right? Or I can make a group with previous two guys, and all the rest of the folks, they will have their own groups.
Okay.
So
you're saying if let's say you pick 12.
Yeah, if
right?
I'm 12,
Okay.
then I can either live alone in my
Okay.
group. In that case, like, rest of the other, like, up to 10, I need like what was the best value. So that's a, like, smaller problem set,
Okay.
right? Or I can make a group with 10, 12.
So 10 and
12.
12. Okay.
Or I can make a group of 5, 10, 12. Right?
Yes.
And that's it. I have no other choices, right?
Mm-hmm. Right.
So if you look at the first one, when I am making a group of myself, does my problem reduce to at least one value already?
Yes.
It's the same problem, but now
Right.
there is one less value.
Mm-hmm.
In the second case, we have the same problem, but we have now two less values.
Right.
And in the third case, like, three values, and rest of the people, they have to do like, solve their problem themselves. Suppose we know the solution for the smaller problems.
Mm-hmm.
Then what is my solution? So suppose S1 was the first case when, like, you have all those, so you have solution from 1 to 10 already. Let's call it S1.
Mm-hmm.
Then overall solution will be S1 plus 12, right?
Yeah.
If we have solution for second case, S2, which has sum from 1 till 5,
Mm-hmm.
then our solution will be S2 plus 2 into 12.
Right.
Right? Because among 10 and 12, 12 is maximum. So both guys will start to get that value.
Mm-hmm.
And then if we take three values, let's call it S3, then overall solution will be S3 plus 3 into 12.
Correct.
So you have now three cases, and the max of that is your overall solution, right?
Right. Yeah.
So then your base case now is very, like, you have up to K if you figure out, and then you can start building up. You have an approach actually to solve this problem.
Mm-hmm.
Okay.
Interesting.
Hey, Roger, are you available now? Can you take over? Because I need to go work.
Yes, sure. I can take over, make me host. Yeah.
Okay, I can stop sharing.
Yeah. By the way, I'm very thankful to you. You came forward. Thank you very much.
No problem.
Okay, guys. So should we go to the next problem, or because it's already 9:08, we have two more problems.
Yeah.
And
Roger, can I have one quick question?
Sure.
Not in terms of whiteboarding, but
Yeah.
so you started with the last element. Is there, I'm thinking, could we have also started from the beginning? Like, is there a difference?
No, you can start from the beginning.
Right, the approach is similar. Okay.
Yeah. Cloud. And we can go to the next problem, maybe. Again, this session is very interesting. I haven't solved these problems. You guys should join. There is a channel, Helps Online, where you can see, like, you can come forward and you can do the sessions. So please join, and you will see, like, who is going to have the session, or you can also say, okay, I can do this session and all. All right. So this particular problem, we are given a binary tree containing digits from 0 to 9. Each root to leaf path could represent a number. Okay. Find the total sum of all root to leaf numbers.
We cannot see a screen of the question.
Oh. Can you see it now?
Yes.
Okay. So yeah, in this problem, we are given a tree, like for example, 1, 2, 3. And so root to leaf, like 1 to 2 represents a number. So 12. Similarly, 1 to 3 means 13. So all root to leaf path represents a number, and you have to return the sum of those. In the second example, which is 495 plus 491 plus 40. So is the question clear?
Yes.
Okay. So now, has anyone solved this problem yet? Or any approach? So let's make this last example. This is 495 491 and then 40. So what you are going to do, 495 plus 491 plus 40. You are given the root as usual in any tree.
So yeah, I am thinking of solving by the pre-order, like using visiting the root first and taking the value in my. For example, I'll be having one current sum, and I'll be taking it into my.
Okay.
And
Yeah, that's it.
then again, doing right. And whenever I reach the end, like when my left and right child is empty or null, then I'll add that in my total sum, which
Okay. Yeah, so what Sonia is saying, I will just reiterate. So Sonia is saying C has a total or something which C initialized as 0. She is going to do this pre-order traversal. So she will start here. And so since it is a pre-order, you are going from top to bottom. And as soon as you will see whether some value is we are at a leaf or not, you are going to add that to your total, right?
yes.
Okay. So when you are going from top to bottom, uh, are you passing anything to their leaves? Like, how will 5 know that it has to get 49 somehow, right?
So yeah, I'll be taking one one current, like where I'll be adding that, like how we are adding like multiply by 10 and then plus root value. That would be the like normal appending how we do.
Got it.
So yeah, that's one thing. And whenever we reach the end, or you can whenever we reach the end, either you can append in a list of that part and then do the addition at the separately, or you can just do it at that point as well. You can do that.
Got it.
Yeah.
Roger, Sonia, just building on your idea. So correct me if I'm wrong. So are you saying, so you are suggesting that, we do this traversal and then we keep this running sum and add it. But so we first have to form a number, right? Like 495, like you were saying, multiply by 10. So would it, like, why are we keeping a total at that time? Don't we have to first come up with a number?
So yeah, that's what I'm current is like one number, whatever the number
I see.
Over.
Okay.
Yeah. So like how we form the number normal in.
Makes sense. Thank you.
I am not getting any that question that the reverse question or something like that. How we find the number.
No, I got it. I think I was confusing with the sum part of the question.
So sum is like, sum can be done at the end. Whenever you form a number that can be appended in a list, and then you can do it. Then you can sum the list. other part is you can make a total sum and then just add it whenever you reach it.
So this is how Sonia is doing it. I will try to explain here. We'll go through this quickly. So all these leaf nodes she is adding into this total. And what she started with n is basically a current tree node. So it's not like we are passing the same n to here. It's this existing node. I'm just showing it that's the parameter she is passing.
Right.
Most important is this value. She started with 0. Now when she is going to the left side, she needs to pass like what was the so far what I have seen already. So she sent 4 here, she will send 4 here too. And then when we came to 9 and go down, now 4 and 9, 4 came from the previous level. So she is going to do into 10. So 4 into 10 plus current value. So she started passing 49 here.
Makes sense. Yeah.
And so on.
Yeah, thank you.
Yeah, no problem. So yeah, this looks a good approach to me. And what's the time complexity?
So we are traversing all the nodes. It could be anywhere, and is the number of nodes.
Give me a minute. Actually, let me mute. Whoever is not speaking should mute themselves. Actually, I can't mute people also. I don't know why. But anyway. Strange. Okay, guys. So what was the time complexity?
So on the worst case, we are traveling all the nodes, and we have to travel all the nodes to find the paths and to total it down. So n is the complexity, where n is the number of nodes.
Sounds good to me. Anyone has any other approach?
My approach is to use the DFS to recursively iterate from the root to the leaf and each node value to a string. When it's reached the leaf node, I transform the string to the integer to an integer and put that integer to array. And the last step is to sum up all the integer in the array.
Right.
The sum, yeah.
Okay. So yeah, that's a good approach. By the way, do you guys think that DFS includes pre-order, post-order, and in order? Is that clear already? I mean, I'm talking about DFS. I don't know whether you said BFS, but I think in DFS, all these kind of pre-order, in-order, post-order traversal is part of DFS. It's a food for thought because it's recursive. You do the same thing. You just change the order of your function call. That's it. No other difference. So it's a superset anyway. So what Sonia suggested is also a DFS. Another way I haven't solved, but I can think like if we do BFS, for example, and if we keep passing a value to each next level, this should work too, right? At each level, we will.
Yeah, it would also work like BFS. Yeah, like adding your value at the next.
Yeah.
But the time complexity for each one will be.
It would be same because ultimately you are traversing the nodes only. So like the size of it. So,
right.
Yeah.
Right.
So space would be different, right?
What space?
Space would be different, right?
Yeah, as in any BFS or DFS problem, space could be different. And then again, you go to in that, like, you know, when DFS is better, when BFS is better. So as you guys already have talked about in previous classes, if you have this kind of tree, then maybe DFS will not give you the, like, you know, best space. Because if I do BFS, then at each level, I will only add one node, right? That would be your, in case of DFS, that is your like over worst case space complexity. For BFS, you will be thinking about this value, which is on the leaf node. So yeah, I mean, it's good to talk about. And I hope that everybody, like, you know, who went through previous sessions, they know when to use what, or at least talk about it. Did I answer your question or not?
Yeah.
Okay. Do you want to add anything or any questions?
Roger, I have one. Sorry,
Sure.
somebody was on the line. Yeah.
The thing is, I can't mute people. For some reason, it's not working. I'm not able to mute people, and people who are not talking, they should mute themselves. So sorry. Yeah, go ahead.
Yeah, so Roger, coming to this quickly about DFS versus BFS,
Mhm.
in terms of complexity, I'm thinking it might be, similar if we keep aside this discussion about, if it's a skewed tree and all that.
Mhm.
But if we are even thinking about, let's say, a constant extra effort, which won't add to the complexity, but if, for example, in this tree only, if I
Mhm.
go DFS, then we are doing 495 and
Mhm.
then we are doing 491,
Yeah.
right? So we are kind of traversing, 4 and 9 like 2 times just in this path. Whereas if I do BFS, then isn't it that once I have 4, 9 and 40 done, then I just go to the next level and I'm not adding that, the second walk.
Okay. So
I don't know if that makes sense. And it's kind of a very, like I said, it probably won't matter in complexity, but still it's an extra effort, right?
yeah. So what you are saying that, okay, we went like this, and then we went like this. So is at this point of time, nine was touched 2 times, right? That's what you're
Yeah,
talking about.
yeah,
And then you are going like this.
right.
Yeah. So in terms of complexity, as you talked about, doesn't make any
Yeah,
difference.
right.
So this, since this thing is handled by our stack, this value was kept there. So there was a context switching, kind of context
Oh,
switch.
right. Makes sense.
So from here, it will get some value and then it will go and proceed further.
Correct.
So,
Okay, so that won't be much overhead. Yeah,
so
thank you.
yeah, it is. Yeah, but then in Q you also maintain some state now,
Right.
right? So kind
Yeah.
of like it's good to try
Yeah,
for
it's
it.
more like just brainstorming, but yeah, you
Yeah,
answered my question, Leela. Thank you.
yeah, no problem. So are we good with this problem? We talked about 2 approaches which could work, and then time complexity, space complexity, and then we can go to the last problem for today.
You're going with BFS, you need to maintain it a pair like that, right?
In BFS you are talking about, right?
Yeah. Suppose if you're at 9 or 0, you have to maintain that node as well as I mean, the resultant value is 4, 9 or 40 with that particular node as well, right?
So as I talked, I haven't solved, but what I'm thinking, if I am at any place, like if I am thinking like I am here, so I will have this value 4, that my previous level had this value 4 so far, right? So when I am processing 9, and of course 9 is not a leaf node, so it doesn't matter, but I will start passing, as you said, next time, like, all these guys should get 49, right? So 5 should somehow get that, hey, my parent already had value 49. For 0, we had like, which is a um, node without children, will have directly 40. So 4 into 10 plus 0. So we'll have this total which we had, and we will keep adding these value. So on each level, we will have couple of these values. This we pass to this level. So this level, like at least this children, like children of this guy, they all got past this value 49, right? So you are passing, if you were talking about, if you are passing a pair, so that is a good implementation, I would say. Yeah, we are passing a pair. One is what you got from the previous, your parent, and what is your node. So I think that's right. By the way, that was your question. Did I understand it right?
Yeah.
Okay, yeah. Sounds good to me, actually. That's how I would implement. Any other question, guys? I think we are good. All right, so we'll go to the last problem. Oh, I have. I have no idea what I am sharing. So yeah, maybe. Now you can see the problems. Maximum score words formed by letters. You can see this problem, right? This particular problem.
Yeah.
Okay. So what is this problem? Return the maximum score of any valid set of words formed by using the given letters. Word cannot be used 2 or more times. So, okay, dog, cat, dad, good. And letters are these. Okay. It is not necessary to use all characters in letters. So we can leave some of the letters. Okay. And also we are given a score for each character. So, okay, I see. So you have 3 things: letters, scores, and words. So now what we have to do? So we have to build maximum score. Okay. So let me try to understand this problem first. A has value 1. So A's score is 1. And then 9 is a score for C. For D, the score is 5, and so on. So, okay.
No, so it's, yeah, so it's alphabetically, like you can see the letters are repetitive in A, B, D, D are repetitive, but in the score, they have given the max value of that character, like max, it's A to Z only.
Yeah.
And for example, 9 stands for C, and similarly 5 is.
Yeah, they have actually given 26 values in the scores, and each of the score corresponds to one character in the small case English character.
Okay.
Yeah.
So, okay, yeah. So A has a score. So I was saying in the other way. So A has a score 1, C has a score 9, D has a score 5, right? Oh.
Yeah, that's how I'm reading it. Yeah.
Oh,
Yeah.
I see. Oh, so I see. Okay.
Yeah, people get confused like that. Yeah.
Got it. So, okay, depending on this, I have to see, okay, if the letters are 0, A, C, D, D, G, O. That's interesting.
So there is no relation between letters and score.
There is no score. Yeah, relation between letters and score. Okay.
Yeah. So score is always 26.
Yeah. So if I just look at a score, I know the score for each character, right? Because
Yes.
there are fixed 25 characters, 0 to 25. So that's fine. Okay. So this is just giving me how many characters of each type I have. That information I have, right?
And yeah, you need to use at most 2, I think they have written. But no, but there is like at how many letters are present. For example, in second example, there is 3x are there. So I think we need to use all the letters, the letters present over there.
So the letters give you the frequency number of letters available, so you can use maximum those letters.
Okay.
And cannot repeat. So
okay,
if you have 2A, so you can use only 2A to build the word.
Okay. Let's go through the example. One example we'll see. Maybe, so we know like a score for each letter, that is clear. We have letters array. Based on that, I can tell how many letters of each type we have. And then we have words. So we can only form only use letters to form one of these words, right? So every time I use a letter to form a word, I'm losing count of that letter, right?
Yes.
So, okay. And also something was not repeating, like there was somewhere.
So each letter can be used once, which is same thing about decrementing the frequency, right? Every time.
And for particular word, actually, for particular word. But you can use for other, for particular word, you need to use that many characters. Like in the last example is their lead code. So there is.
So let me actually, whatever my understanding is so far, let me look at the bound first. What is the bound? I have something in my mind. I just want to confirm. Okay, words length is 14. Words I length is 15. Letters length is 500. Okay, so there are only 14 words. It's a very important information. And the score length is 26. The score is I. Words I contains only English letter, which is good. Okay. So let me try to explain, and you guys can help me if I haven't understood the problem fully. But this is we have three things. One was, which was the easiest to come up, was a score. Score has 0, 1, 2, up to 25. Like for all these characters, you have a score, right? So this is a score for A, this is a score for B, and you can have any score. 0 and 1 represent just index, but A can have a score 9, B can have a score 5, anything can happen like that. So that was the score part. Another one was letters. So we are given kind of count of each letters. So in a way, A has occurred 5 times, B has occurred 3 times, something like that. We can have all these things. There's something on chat. Can somebody look at it? Is it? Okay. Yeah, that's fine. So we have this thing. This is clear. Now they have words also. So suppose words were, I'm just taking example, dog, cat, something else, mouse, whatever, these kind of words. Now my understanding is, suppose I have 2 D's, 2 O's, and 2 Z. I cannot make this word 2 times, even though I have 2 of all these D, O of G, right? So that is one of the restriction I think was put, that you cannot repeat a word while forming this. Does that make sense?
Yes.
You can form a word like DOG. You can form like you have 2 characters.
Yeah, so first time I can form DOG, but I cannot form, because now after one DOG, I have 1 of D left, 1 of O left, and 1 of G left. So I cannot again use, I still have like, one more pair of, I can still build one more DOG, but that's the thing, problem is saying that you cannot repeat this word again while building it.
But actually I'm getting confused because in second example, if you can see, there is triple X G Z, and triple X is formed by one word, but there is another X, AX, BX also there, and they are forming the words. Like there's a possibility.
No, they are making only AX one time, BX one time, and CX one time. They are not repeating or building the AX multiple times.
So yeah, so if one X is also one X is used, then also they are using the three X's as well. Say all the three X's in making another word, three X's.
No, they are not making. They are saying that either you can make AX, BX, CX, or you can make XXXZ.
Okay. Yes.
Yeah. So
we
the
need
key is
one word only to which one is a maximum, or we can make total max. Okay.
Yeah, basically think about items. You can bring only like, one particular item of type in your house, for example, for some reason. So you don't have to bring two items of that at the same time, but you can bring AX plus BX plus CX because you are not repeating those. Does that make sense? If I have enough X's, then I can even bring all the four guys. That's fine, as long as I'm not repeating it. But suppose I have too many B's and too many X, then I'm not supposed to like, bring like, tens of BX basically. That's what I'm saying. You cannot repeat after you have, if you have like, processed one such words, then that's it. So does that make sense? Problem is clear, guys?
Yes.
So, but if the list of words, if it has that duplication, so it should be okay, right?
So you are saying if
I think, yeah, because like if the list of words, whatever the words are there in the list, those are the only ones we should, if it has a duplication, then we should be fine. That is what I'm thinking.
Yeah, if you are saying it is BX again, then for sure, yeah, you can bring it. So your index is changing at least, right?
Right.
Yeah, then it should be okay.
Okay, thank you.
So any approach, any idea?
And one more thing, like, like if you take an example of cat, so the score for T is 0. So does it mean that we should actually not consider cat at all in the counting? Because I didn't understand that.
Yeah, because you are not having the T in your letters provided to you. So I think we will not be able to create that word.
Okay, but in case if it was included, but the score was 0, should we include that or no?
What do you think?
No, because I was confused over there. So I thought maybe we should not include.
Yeah, I mean, that is a fair, I think, question, and I think right answer. If everything is positive and like, all these values I am like, spending in vain, then I will probably not waste those.
Oh, okay.
Yeah.
Makes sense. Okay. Thank you.
Yeah, that should be the approach. But anyway, like personally, I think looking at a couple of things, I have some idea in my mind, but you guys can go ahead and talk about if somebody has solved it already or anything you have in your mind, how to go about solving it.
I'm just thinking, first of all, we need to create the frequency of the letters which are present in a dictionary.
Yeah, we have to, because to decide, we have to create frequency array.
Yeah, and then start traversing the words.
Yep, so you have this frequency map you call or array, depends how you represent, but yeah, you have that, you built it. And then
where A is like the character is the key and the value is the frequency of it, and then start traversing the words. And while traversing, just decrease the count in the frequency and take the score of that character.
Okay.
So my question over here is, and doubt is, we need to maintain the frequency, like for other, when, for example, one we have traversed the one word and we have one score of that word. So we need to move further for another word. We need to change our, like we need to use the only that dictionary, or we need to make it the before it was.
Right.
That is one I am confused, because
So,
if we can use the words, if we have to use the words with characters which are left, then the same dictionary is followed. But if we have to reset, then yeah, then need to be considered.
that's right. That is a good approach. I liked it. So in one word, if I have to say, like, there is a particular thing you are doing, like what is this paradigm called? What you are trying to do? You
like
are
actually for me.
What? Can you repeat?
It looks like a 0-1 knapsack for me, but I couldn't formulate the equation as such. I mean, you can either pick the word or not pick the word. I mean, a 0-1 knapsack and...
Okay. 0-1 knapsack. And you can either pick or not pick. So that's why this 0-1 also. And so you pick this or not. Then you can pick this or not. And it all depends on how your frequency, like how much you have got, right? You can continue making those decisions, right? I mean, it looks to me, what I was trying to hear was backtracking, but same thing. Because what we are going to do, we will choose AX. So I will reduce my frequency value. For example, suppose I was able to build AX. Then my frequency count has been affected. Now I have less characters. Then I will move ahead. Now this is my set of words because I have included AX. So now I can only look further with a smaller frequency value, right? I will continue doing that. I will build some score, suppose X1 finally, when I exhausted that particular branch of search. Then my second, decision saying don't include AX. If I don't include AX, then my frequency, which I had created, remains the same. We just start to the next guy and continue. So at every instant, you are making two choices to include it or not, and so on. You are going through like this. And your value of index changes. Things which are changing is your frequency is changing and your index is changing. So you have two dimensions to worry about. Keep passing this to the functions. And whatever solution you will continue to get for the max, you can globally keep it maybe. And then you can say, okay, this is the best I got. And in any backtracking algorithm, as Sonia was suggesting her idea, now you have chosen this value. So you spent this much, your frequency was something else here. Suppose your frequency was F1 here. You made a decision to continue F2 here. You made a decision, now you have F3 here. Now when you go here and you go to this branch that, okay, don't choose, you have to make sure whenever you go back and go to the different branch, make sure you are passing the right value of frequency. So in any backtracking algorithm, you do something, and what we do next, when we return, we just undo. same thing. So you have to go back and you have to again change your frequency, or at least make a change to the frequency to reach to the same place where you were. And one more thing which we looked at, the bound was pretty small. When you see things like 15 and things like that, we already shared this in one of the session, like what these number, somehow these number give you a idea what could work. So that can also tell you that, okay, it backtracking may actually work in this particular situation. So any doubt on the approach? You have to implement it for sure, but you know what you are going to do. You first create a frequency map, then you go through each word. I will go through each word. For each word, suppose I selected that word. If I select that word, then I will update my frequency. Make sure that you are you able to even build that word or not. If not, then ignore that path. We call it pruning basically in backtracking. We prune that search space. If we can build that, then I can update my score, and then I can continue going to this further depth in the same path with this less frequency now, and my search space will be different because now I cannot include this word. So I can start from the next index. We'll continue doing that. After that, when we finish that search space, we make sure that we undo that, whatever I have changed. So in this particular case, I had changed this frequency array. I will just undo that. And we'll keep a count of something, which is what is the best I have created so far. And that would be my result. Does that make sense, guys? Like it's all backtracking problems have similar approach to solve. Like you start with something, you make a decision, then you continue into that path, or you prune that, and whatever decision you have made, you undo that because you know that I have to again start over for a different search space. So you want to go to the same state where you would have made that decision had I not taken this path, what I had with me. So that's why we do this undo thing. And then we move ahead, and after you look at some of the code or you go try to solve it, I think it will make sense. Anyone has any other approach? Want to talk about time complexity a little bit? So this should give you some idea about time complexity, because every time we are making two decisions, should I include this word or not? So 2 to the power n, if I say n is total number of words, if this was n, then 2 to the power n for sure. But for each word you are going to build this frequency, you will do that check. So you can have that take average length of each word, some value. So that word length, that will roughly give you the time complexity. All right. Any questions? Okay, looks like everybody understood it then. So if there is no question, then we'll stop recording. I can take, I will be available for 2-3 more minutes if there is any question. And I would, so yeah, first let me stop the recording if there are no questions.